Thank you, Mr. Chairman, and good afternoon, everybody. I'll tell you this afternoon a little about technologies in exploration and extraction of marine sand and gravel. I'm a little bit surprised that these resources have not been mentioned in any of the presentations so far, but here we go. In this presentation, I will first shortly tell you about the where to actually look for these resources in the Finnish marine areas, and then what kind of techniques you need to actually find and locate these sand and gravel deposits, and then what kind of techniques are used to then extract the material. And then a few words about techniques on how to monitor the actual extraction activities. This is especially for the regulating authorities. So this is an a map of the occurrence of the sand and gravel deposits in Finland on land. And as you probably know, most of the sand and gravel deposits are eskers and end moraines, and they are formed in last glaciation about 10 to 15,000 years ago. And the eskers run mostly in the northwest to southeast direction because of the center of the glaciation. Last glaciation was here in the Gulf of Bothnia area, slightly on the Swedish side, and that's why the orientation of the eskers is like that. And you can expect these eskers, for example, here in the Gulf of Bothnia, to continue here in the marine areas as well, or actually they originate from the marine areas and continue on land. That is actually what has happened. So you would expect to find these deposits on the water also, but close to the coastal area. They might be eroded due to coastal erosion. It might be difficult to find them. And once you go deeper, in deeper water, further out to the sea, the eskers, especially, they are better preserved, and they are more in their origin form, so they are not eroded, but they can be covered by younger sediments. So now that we know that we might find some formations here, what do? We go out to the sea with the survey vessel and use seismoacoustic survey methods. This is an example of GTK's research vessel Geomari, and it's equipped with a variety of sensors. We have SWOT systems, so-called SWOT systems like multibeam and side scan, where we can cover large areas of the seabed and get detailed information about the depth and the quality of the seabed itself. But we also need then profilers like Pinger, Chirp, and sub-bottom profiler, so that we can get information under the seabed also. So then by combining this data, we can easily locate and estimate the possible formations. And here is an example picture. This is actually from the Gulf of Bothnia. This is the continuation of Vattajanniemi Peninsula, and the esker. This is roughly, I guess, 10 kilometers from the shoreline. And this is a picture of the low-frequency seismic profiler. We can actually, this is the water column. This is the seabed here, and all this material here is sand and gravel, And as you can see from the figures here, this is quite a large, very huge formation. It's about 1 kilometer wide and several tens of meters of thick, so there are millions of cubic meters of material. We can quite nicely locate these and calculate these formations with the use of these acoustic seismic methods. Okay, so now we have found the sand and gravel deposit, so now we need to take it up. So how do we do that? We usually use a suction hopper. This one is a trailing suction hopper, which means that this is moving on. It circulates over the deposit, and these suction heads are in the bottom. This has two drag heads, are called this one. They are a few meters wide, and they suck the material or mixture of this material and water into the vessel. And this leaves like tracks of few meters wide and maybe 10 to 50 centimeters deep. Another option is to use this vessel stationary so that it doesn't move. It just puts the drag head to the bottom and then sucks from one place. Then we end up with deeper pit holes like this. Here are some multi-beam pictures. These are offshore Helsinki, where dredging of sand and gravel has been taking place in the 90s. So here we see tracks of this trailing method, and here are some pit holes of this static method. So if we use this method, it affects a little bit, maybe larger area, but the bottom stays a bit smoother. This one doesn't affect that large area, but it leaves more visible pit holes. Then how to monitor these activities. This is an example from Belgium. All dredging vessels are or can be equipped with sensors. This automatic identification system, AIS, this is a normal thing in all the vessels, so you can see where they are moving. And also the suction pumps can be equipped with sensors, and this data can be sent online to authorities so they can monitor almost online where the dredging vessels actually are moving, how much they are extracting, and so this is a so-called heat or intensity map where the dredging has been taking place. You can also, of course, monitor that they are in the permitted places, so that they are not moving outside the areas. Then, of course, after the dredging, a multi-beam survey can be done again, so then it can monitor what has actually happened and see what kind of tracks there are in the bottom. Are they as they were licensed, and are there still something left here maybe, and other things too. And last thing of this subject, I will give a short newsflash, because the Ministry of Environment has established a working group on this subject, and there are some members of this group. I am in this group. There are others here in the audience too, and the aim of this working group is to establish good practices and guidelines for marine sand and gravel extraction in Finland, and this working group should report its work next year. So then we will have set guidelines, and also these techniques that I told you are probably presented there, and and used then in the future. Thank you for your attention.
Thank you, Jyrki.